So here's the legal disclaimer. The opinions in this talk are mine. They're not those of HGS. A lot of the work was done with for AAPG. It's not the opinions of AAPG. And they're not the opinions of any company I am associated with, past, present, or future. The talk does not meet the approved standards of political correctness and contains occasional statements of humor. Should at any time the listener feel offended by statements contained within the talk, listening should be discontinued. Side effects of continued listening can include, but are not limited to, feelings of righteous indignation, anger and rage, and uncontrollable urge to insult or even assault the presenter. If you are experiencing those symptoms, you should leave the talk. If they persist, you should seek professional help. So let's look at what we're going to talk about here. What are global temperatures doing, and why are they doing it? It's a politically charged subject, but I'm going to try and keep this as science-oriented as possible. And the reason we're here is we have this hypothesis, anthropogenic global warming. It states rather simply that humans have caused CO2 levels to increase, and those increased CO2 levels have caused temperatures to increase. If we look at Dr. James Hansen, one of the key advocates of AGW, he's commented that recent warming coincides with rapid growth of human-made greenhouse gases. And he has commented that the Earth is warmer in 1988 than at any time in the history of instrument measurements. If we take it to the more uninformed voter level, the Earth has a fever. And if we don't change, civilization will end in 10 years. Now, my apologies to those of you who are celebrating surviving the end of the Mayan calendar, because the Gorpocalypse is now just 2 years and 11 months away. So global warming, is this a real crisis? And we're going to look at 4 questions to determine if it's a real crisis. The first, what are global temperatures doing? Why are global temperatures doing what they're doing? What will global temperatures do? And what are the consequences? Does it matter at all? So question 1, what are global temperatures doing? Well, the IPCC, which is from the United Nations, states that warming of the climate system is unequivocal. NASA, under the direction of James Hansen again, has stated that the 5 warmest years over the last century have been 2005, 1998, 2002, 2003, 2006, and we're now hearing 2012. All of this stems from the hockey stick curve, which was published by Mann and Briffa. And in the hockey stick curve, we can see the temperatures have declined 0.3 degrees from 1000 to 1900 AD, at which point they took a rather rapid and unprecedented increase of 1 degree. So looking at some of the various published temperatures, we do see that they vary a little bit from agency to agency, but they all show basically the same trend, and that is rather strong warming from about 1820 to 1850 time frame. But in looking at these, you have to understand that these curves are averages, and they're based on an assemblage of data. They exclude some real data points, they add extrapolated data points, and then the data is processed. So if we look at the stations that are used to collect the data, there's 5 classes depending on how compliant they are with NOAA standards. If we look at the temperatures taken from stations class 1 and 2, which are compliant, we see that on average they're adding, or they show a warming bias of 0.155 degrees centigrade per decade. If we look at the non-compliance NOAA stations, those are the stations that are in parking lots or next to crematoriums, which, by the way, there is a station in a parking lot next to a crematorium, so that's pretty non-compliant. These add or show a warming trend of 0.248 degrees centigrade per decade. Now, when you put all of those together, you should see something on the average between 1.5 and 2.4. But we actually see 0.309. So somehow combining a 1 and a 2 gives us a 3. So apparently they're additive. But we're seeing then that the NOAA curve has a warming bias in excess of 0.15 degree per decade. Now once the data is collected, it's homogenized. And here's the map here shows the red triangles are those stations where the process of homogenization has increased the temperature to a positive trend, or it has decreased the negative trend, or it has changed the negative trend to a positive. And 2/3 of the stations show a positive or an increase in the temperature range. If it were truly unbiased, it would be about 50%. So the process of homogenization is also adding a warming trend. And then it's processed. Now most agencies will not release the algorithm or the formulas that they're using for the processing. New Zealand, here's their processed curve. A few years back, were sued under the Freedom of Information Act in New Zealand and were forced to release the unprocessed curve. There's the raw data. So obviously, the processing algorithm or formulas that they're using impart a warming bias. So what are temperatures doing? Obviously, the answer is just not that straightforward. So let's come back and look at the situation a little more in detail. This is a plot by NASA published in 1999 from all of their GISS stations, which is the Goddard Institute of Space Studies. And we see there's a lot of scatter to the data, but there's a generally downward-oriented trend. In the paper that this was published in, James Hansen made the comment that in the U.S. there's been little temperature change in the past 50 years. And that's a time of rapidly increasing greenhouse gases. In fact, in 1999, he recognized a slight cooling trend. Now, the paper was addressing a major drought, and his comment at the time was that the 1988 drought was a temporary inconvenience when compared to the droughts of the 1920s and 30s. So there's Hansen then. So 1999, he's saying in the U.S. there's been little temperature change in the past 50 years in a time of rapidly increasing greenhouse gases. Hansen today says recent warming coincides with rapid growth of human-made greenhouse gases. So a bit of a contradiction there. He also commented in 1999 that 1988 was a temporary inconvenience compared to the repeated droughts of the 1930s. And today he's saying the Earth is warmer in 1988 than at any other time in the history of instrumental measurements. So what's different between then and now? What's caused him to change his mind? So let's go back and look at then. So the red curve on this is the NASA average, and the black lines are the means that vary from year to year. That was the 1999 curve. And there was the 1930 Dust Bowl, and there's the 1988 high that he was talking about. We also noticed that there was a cooling trend from 1920 to 1999. That's what he was talking about then. Now let's look at the NASA curve today. So here it is. Again, the red curve is the 5-year mean, and the black is the annual means. There's the 1930 and the 1988. Now 1988 looks a little warmer now than it did in the last curve. So let's look at the two curves side by side. And what you can see is that from 1978 to 1990, it's warmer today than it was in 1999. Somehow. And if we look at 1985 to 1935, it's cooler today than it was in 1999. If we take the NASA curve and compare it to the 1975 National Academy of Sciences curve, you can see that NASA's present-day curve is showing considerably cooler temperatures in the pre-1940 range. By the way, this is the downward the temperature trend that precipitated the 1970s global cooling scare. So let's come back and look at these three plots, by the three most published plots. The NASA data, that's altered. It's been altered between 1988 and 1999 and today. So we can't really use that curve because I don't know how it was altered. The NOAA curve, we saw that the data distribution tends to add a warming bias. That leaves us with the Hadley curve. Now the Hadley curve is generated by East Anglia University in Britain. It is the Climate Research Unit. They have admitted that they would rather destroy their data than release it to Freedom of Information Acts. So what are temperatures doing? I still haven't been able to really get a good answer to that. So let's go in and look at some individual temperature data. This is from Kuala Lumpur, where I live, and it's been flat and warming, so obviously it's getting hotter there. Here's Surrey, UK. This is not too far away from the East Anglia University, so this is the Hadley data set, and they're kind of warming too. Go to Washington, D.C. We see a trend that kind of goes up, down, and up. No relationship to political cycles whatsoever. And we see, though, that the last couple decades we've seen a pronounced warming trend. So let's come close to home. Let's look at Houston. I've actually gone up to Brenham because it's got a long temperature record and it doesn't have the impact of the urban heat island. And what we see is that we had warming, then cooling, and then warming. So that seems to be a pretty pervasive trend of warming, cooling, warming. Unless, of course, I look at Houston, Texas. Now I went to Brenham here so I could avoid the urban heat island effect. And what we see here is a pretty pronounced cooling trend. Now I haven't misspoken here. There are the two curves side by side. The cooling trend was taken off of NASA's website in 2008. The warming curve was taken off their website in November of 2012. So there's the 20-degree mark for reference, and you can see a couple of changes. One, this high spike in temperatures here in the early 1900s was removed. We've added 2 degrees of cooling to that portion of the curve. We've added 2 degrees of cooling to that portion of the curve, and we've removed that cold spike. So the data's been altered to show an artificial warming trend. Let's go back to Washington, D.C. We see again the same alterations. There's the 12-degree temperature reference, and you can see we've got 2 degrees of cooling added to this portion of the curve, and we have another 2 degrees of cooling added to that portion of the curve, and we've had 1 degree of warming added to that portion of the curve. So again, the NASA database has been altered between 2008 and today. So if we go back to this statement from NASA, that the 5 warmest years over the last century have been 2005, 1998, 2002, 2003, and 2006. Back in 2008, that was true for only 1/3 of the data, and I've looked at over 200 individual station data. You can't check it today because the data's been altered. Let's go to what the IPCC says. The warming of the climate system is unequivocal. Well, in 2008 and 2009, that was true of only 1/3 of the stations that showed a clear warming since 1970. 1/3 of the stations were flat, and 1/3 of the stations showed a general cooling trend since 1970. So how do you average that? Let's go to the Philippines here. We'll look at 3 temperature profiles. And what we see is that Tagbilaran has been increasing in temperature, where Mactan has been cooling, and in Lekbazvi, and I don't speak Philippines, so I don't know the pronunciation of those, it kind of goes up and down. So what does that mean about averages? Well, again, here's NASA's average curve showing everything going up. We see some curves going down, some flat to going down, others going up. So these averages aren't really meaningful. It's kind of like this cartoon. defining rain at the rain gauge as above average rainfall globally. To put it in terms our industry can understand, if you drill a gas well, an oil well, and a dry hole, it'd be like going to management and saying, on average, I have a low saturation condensate play. It's meaningless. So what are temperatures doing? And the answer is, they're changing. Now, they are changing in cycles of multiple wavelengths and amplitudes. If we go back to the Precambrian, we see that we have temperature changes with a wavelength of 150 to 200 million years and an amplitude of almost 15 degrees C. If we go back to the Cretaceous and look at the Tertiary, we see a wavelength of 15 to 20 million years and an amplitude of about 4 degrees. If we go back several 100,000 years, we see a wavelength of 100,000 years and an amplitude of almost 10 degrees. By the way, the latest warming trend, right there, started 15,000 years ago, and I'm pretty confident that that wasn't human caused. If we look at climate changes over 100 years, we see a wavelength of between 600 and 700 years with an amplitude of 0.6 to 0.8 degrees. Then we see wavelength of 30 to 40 years with an amplitude of 0.5 to 0.6 degrees. And finally, we see wavelengths of 3 to 5 years with an amplitude of 0.3 to 0.4 degrees. So temperatures are changing cyclically with multiple cycles and multiple causes. So how much have global temperatures changed? Well, one of the things you have to recognize is that we're always looking at how much temperatures have changed from a reference point. So the most common published curves are in the mid-1800s. Let's look at some different reference points. If I go back to the Precambrian, we have warmed 8 degrees. But if I go back just to the Eocene, we've cooled 8 degrees, so we're no change. If we go back to the Pleistocene, we've been warming, and now we're using proxies for temperature, so we don't have an absolute temperature we can reference. But we've been cooling for the last 10,000 years. If we go back and look at the beginning of our calendar, back to the Roman warm, we're just slightly cooling. But if I change the reference to the medieval maximum, so there's the medieval maximum, here we are today, we're pretty much just recovering from this little ice age. But if I set the reference to the little ice age, which is what all the published curves tend to do, we've had dramatic warming. Now another thing to think about when you look at these plots is note the scales. They're fractional degrees, usually 0.2 to 0.5. If I look at global warming scaled to whole degrees, there it is. That's pretty hard to see. So how much have temperatures changed? If I use NOAA's curve and I ignore the warming bias that I know is in their data set, we've warmed 0.8 of a degree from 1910 to 1998. That is a whopping 0.009 degrees per year. That is not anomalous, and it's not abnormal, and it's not unprecedented. In fact, if you come back to the Houston curve and take the 0.8 of a degree we've seen over the last few decades, we've seen annual variation that's often greater than that in our temperature record. From 1998 to present, temperatures have been flat to cooling. So how much have global temperatures changed? Not much. So why are global temperatures doing? And what they're doing? This is where we get political. The IPCC states that most of the observed increase in globally average temperatures since the mid-20th century is very likely due to the observed increase in greenhouse gases. In other words, humans have caused CO2 to increase, CO2 increases temperature, and therefore humans have caused global warming. Now it's important to note here, the IPCC is not a scientific organization. They advertise themselves as a scientific organization, but they are a political organization put together by the United Nations with the task of understanding a human cause to climate change. That's their charge, and you get what you look for. This is all put together as part of United Nations Agenda 21. If you don't know what Agenda 21 is, look it up, because it will impact you. So, what does the data show? Does the data show that CO2 increases cause temperature increases? And what you see here, what the most commonly published curve is, this is the CO2 levels from fossil fuel use. And there is the temperature curves, and this one goes up and that one goes up, so this is the smoking gun. Now it's important to note that correlation does not imply causation. If it did, my weight could also be an explanation for global warming. And no, I'm not going to put a scale on that. So the smoking gun is more like a bubble gun. But it's not the only flaw in the hypothesis that CO2 is the cause of global warming. So let's look at some of the flaws. Flaw 1, Earth is not a greenhouse. A greenhouse uses glass to create a closed system. The Earth is an open system. We have solar energy coming in and radiation going out. Now I will say that greenhouse gases can impact the amount of radiation going out. So there can be an impact to the climate with greenhouse gases and or CO2. The second flaw, the greenhouse signature is missing. Now the theory is that there will be an increased effect or a hot spot about 10 kilometers up in the atmosphere, particularly over the tropics. But radiosonde data has failed to show the hot spot. So here's what the model says we should have. So these increased temperatures at these higher altitudes, there's the actual temperatures. So the model and the theory don't match. Flaw 3, CO2 is not a pollutant. We exhale it. And trees and plants need it. And there's some recent work that's showing that the higher the level of the CO2, the better the plant community does. Now, more importantly, as far as I'm concerned, is beer needs it. So it's important to global warming. Flaw number 4. Our current level of CO2 is 380 parts per million. Now, that's really pretty diluted. If you were to drink 380 gallons of scotch, you'll die. Unless you mix it with 1 million gallons of water, in which case you're not even going to taste it. Flaw number 5. Water vapor is the most significant greenhouse gas. We don't even model it. They don't know how to model it. So the general circulation models that are the basis for a lot of what is derived about global warming can't account for water vapor. Flaw number 6. The temperature increases actually cause the CO2 increases. So temperature increases precede CO2 increases by 800 to 1,000 years. So it cannot be the cause. We'll come back to see if it's an impact later. The fatal flaw, as far as I'm concerned, is that a molecule of human-caused CO2 is no different to a molecule of naturally caused CO2. So if I go back and I look at the CO2 plot now, this is our increase from fossil fuels. But there's total atmospheric CO2. And we can actually see that total atmospheric CO2 has been declining. Now, a lot of that's volcanic, so it's naturally caused. But if CO2 is going to cause a climate change, we have to be inferring that human-caused CO2 behaves differently in the atmosphere than naturally caused CO2. So what causes climate change? The sun. Okay. So we have solar radiation coming into the Earth. Then our wind system redistributes that heat energy north to the poles, and it distributes cold air from the poles back to the equators. Now the winds also set up a series of major oceanic current systems. These oceanic currents play a major role in Earth's heat transfer, so these are fairly critical to understanding global warming. So if CO2 is not the cause, the question then becomes, can the atmospheric concentration of CO2 become so great as to create the tipping point that you've probably heard about, such that CO2 impacts global temperatures? And that's absolutely possible, in theory at least. But does the data support it? So let's go back to this curve. Again, this is the CO2 emissions from fossil fuel burning. It's not total atmospheric CO2. But we can see a couple of inflection points in that curve, one at 1890 and another one at 1950. So let's go back to Noah's curve. Here's the 1890 change. And you can see a few years after that there is an increase in temperatures. And shortly after the 1950 change in slope, there's an increase in temperatures. And those increases do tend to disrupt what was otherwise a flat or downward-oriented trend. So maybe there is a CO2 impact on the climate. But here's solar activity. So these are M-class in red and X-class in blue. Those are the two most intense types of solar flares. And you can see that there's a few solar flare activity cycles. And when we overlay those on the NOAA curve, each and every one of those is associated with a change in slope of the temperature curve. If we look at solar activity, which is the red curve, and compare that to Arctic air temperatures, we again see a reasonably close correlation, much closer than if we compare that to world hydrocarbon use. And another curve that shows the same thing, we see the carbon-14 isotope, that's a proxy for solar activity. And we see the oxygen-18 isotope, that's a proxy for temperature changes. And you can see again that these two curves plot each other pretty closely. Now I'll have to add the caveat again, correlation does not imply causation, but these are pretty significant matches. And as early as 1998, there was an understanding that cosmic rays influence cloud cover. And some more recent work at the CERN laboratory started to corroborate that. So what you see here is the solar ray activity, and compared that with low cloud cover. So you can see that we do see an influence of clouds associated with cosmic rays. And again, water vapor is the most significant greenhouse gas, so cosmic rays are impacting cloud development, and it almost certainly has a much bigger impact on climate than does the CO2. And again, that's not included in any of the general circulation climate models. Let's come back and look at these 20 to 30 year cycles that we see in the temperature data. So from 1850 to 1880, there was warming associated with the end of the Maunder Minimum or Little Ice Age. Then from 1880 to 1910, we had cooling, with the possible exception of that little interruption there. Then from 1910 to 1940, we had the warming, and that was the warming associated with the Dust Bowl. And then we had 1940 to 1970, we had cooling, and if those of you who study history, the soldiers fighting World War II caught in the Battle of the Bulge or in the Eastern Front were far more likely to die of cold than bullets. And of course, that is the temperature decline that led to the 1970 climate crisis, which was the crisis of cooling. And then 1970 to 2000, we have our current warming crisis. So what's the cause of these 20 to 30 year cycles? Well, they match pretty well the cyclicity of the Pacific Decadal Oscillation. Now we know that Pacific Decadal Oscillation plays havoc with climate because this is the driver of the El Nino cycles. And we know El Ninos, when we have El Nino years, we see enhanced periods of drought in both the northern and southern hemisphere. And this dramatic peak in our climates was an El Nino year. But so are all these other peaks. So the El Nino cycle appears to be one of the key drivers for these 5 to 10 year cycles. And by the way, 2012 going into 2013 now looks like it's going to be an El Nino year as well. So the temperature data reflect a strong control by solar activity and a strong effect of oceanic currents and possibly a weak effect of CO2. So here's the million-dollar question. What will global temperatures do? Well, they're going to change. And they're going to continue to change with multiple cycles of varying wavelength and amplitude. And those changes are going to happen no matter what I say, or you say, or what we do, or how much money we put into research. I would say I'd like to see some research that looks at convolving all of these different cycles and seeing which ones are enhanced trends and which one destruct curves. The IPCC, that political body again, state that world temperatures could rise between 1.1 and 6.4 degrees centigrade during the 21st century, and here's all of their models. Now again, this is a model-based prediction. Now notice that their low case is called the 20th century freeze. And in the 20th century freeze, we still see 0.2 of a degree of warming from 2000 to 2015. But the data says that we've been flat to cooling between 1998 and present. So again, the IPCC models aren't matching reality. So, and all of that, by the way, is in spite of our changes in CO2. So what will they do exactly? Well, we don't know for sure, but the PDO has shifted to a cool phase. And we're in a solar flare and is also going into a very low phase. In fact, I want to show this curve. It's pretty cool. The lower curve here is solar activity from 1600 to 1820. Then the blue curve picks up from 1820 and runs to 1999. And you can see that the curves are very, very similar, which means that projecting forward is very likely we're going to go into this very low solar activity cycle. So I've taken that and I put them back side by side and matched them to the climate. And you can see that this solar activity low here corresponds to the spore minimum, or the Maunder minimum rather. Then we have this period of high. This low is this low that makes the last stage of the Little Ice Age. Then we have our warming trend, and then we're staged to go into this solar activity low, which would be very similar to this solar activity low. So we may very well be going into a period of prolonged cooling. So what are the consequences of that, whether we warm or cool? Well, first of all, I'll show this. This is pretty interesting. About 4,000 years ago, there was a major disruption in the Atlantic circulation system. That caused a major drought in the Nile, so the Nile shrunk, the Sahara expanded, and civilization as it existed at the time all but collapsed. So climate change can have pretty dramatic influences and impacts on human society. So what are we facing? Well, let's look at some of the claims. IPCC says the sea levels will probably rise between 18 and 59 centimeters. This is why everyone that lives on the coast needs to sell their property now. Well, let's look at the historic averages. And what we see is that sea level historically has been rising at a rate of 7 inches per century. And this is associated with post-glacial. And there's no real change in the slope of that curve. So if I take the 7 inches per century and project it, we'll reach the IPCC prediction in the year 3000. So if you were thinking about selling your beach house property, you might want to wait. And if we go into a cool phase or another mini ice age, then sea levels will actually drop. Another claim by the IPCC is that there is a confidence level greater than 90%. There will be more frequent warm spells, heat waves, and heavy rainfall. Well, here's the data for that. So this curve shows the average number of very heavy rain days. or average consecutive dry days there, and the average number of very heavy rain days. And you can see there's no increase in overall trend. It's pretty flat with lots of cyclicity. And finally, their prediction is there's a confidence level greater than 66% that there'll be an increase in droughts and tropical cyclones and extreme high tides. And everyone's pointing to Hurricane Sandy as evidence of this. But here's the actual hurricane activity. So the red curve is wind strength, and the blue dots are number of severe storms. And you can see again that those trends are overall reasonably flat with some cyclicity to them. And if we look at going into 2010, we're at a 30-year low for cyclonic storms. So, if we take all three of those statements together, they're all wrong. Let's look at some of the headlines. Greenland glaciers are disappearing. They're retreating at a record pace. So let's look at glacial melt here. So here's the glacial retreat curve. And you can see that it's about a 180-degree trend. And if you compare it to the sea level rise curve, you can see that they're pretty similar, because the sea level rise is largely a function of glacial retreat. Here's the Arctic in 1979. Here's the same area in 2003. Notice all the ice is melted. And I don't have a similar picture, but here's the 2008, and all the ice is back. And what we see then is that global sea ice area also changes cyclically. Here's a picture from the North Pole in May of 1987, where we had 3 submarines surface right at the North Pole. And you can see lots of open water in the North Pole in 1987. All of which was gone in 1999 when that submarine visited. So if I redisplay the global sea ice area now, so I squeezed it to match this horizontal scale, and I stretched it vertically just so you can see the cycles. Global sea ice patterns are cyclic. Now they're not quite a match to the temperature cycle, so there's probably another cause behind sea ice changes, but the sea ice changes are cyclic. So if we go back to the headlines, the Arctic seems to be warming up. Reports from fishermen and seal hunters and explorers who sail the seas about Spitsbergen and the eastern Arctic all point to a radical change in climate conditions and hitherto unheard of high temperatures in that part of the Earth's surface. That was a headline in the papers of 1922. In other words, we've been there before, we've done all this, the Earth survived, and the polar bears have done quite well. Let's go back to Greenland. So Greenland ice is disappearing. Well, this is what Greenland looked like in 876 when the Ericssons showed up. They found a greatly reduced ice mass in Greenland, and they set up an agricultural community there. So we've been there and we've done that too. If we look at Kilimanjaro, 1970, lots of ice. 2000, not so much. 2008, lots of ice again. And some very recent satellite work in Pakistan and Western China and the Karakoram ranges have shown that our Asian glaciers are growing, not shrinking. So is this a real crisis, or is this just alarmist hype? Well, here's page 1 of a list of all the things caused by global warming. Now, I'm not going to read this, but I'm going to point out a few things. 1, Antarctic ice is growing and shrinking. So somehow global warming does both. So maybe it's that cyclicity we talked about. Bunch of things in here don't make sense in terms of global warming, like fish catches are rising and they're dropping. I didn't know if that was related to global warming or not, but apparently global warming is making fish death and it's causing them to get lost. So that's probably got something to do with it. So then we have can't read it from here, Black Hawk Down. Now, I thought that helicopter was shot down with bullets by Somali terrorists, but somehow the falling of Black Hawk Down is climate related. Another one, circumcisions are in decline. I don't know how we're going to survive that, but... And then there's better beer. Now, obviously, that's important to me, and I really started thinking about maybe I'm on the wrong side of the fence on this issue, especially when I noticed that it's also good, global warming is causing great tits. When I dug into that a little bit, though, it was European songbirds, so I gave up, and I'm sticking on my side of the fence here. A rift on Capitol Hill. Now, last week I gave a talk at the dinner meeting on rifts. I'm a Rift Basin fan. And especially since that global warming is causing an increase in tectonic activity, I thought, man, we're going to get a rift basin under the Capitol, and that could be good. Then I read that a little further, and I found out that the rift they're talking about is political, not geologic. Now, the big rift on Capitol Hill today is the debt. And then it hit me. Global temperatures are going up. The debt's going up. It's the smoking gun. Global warming's caused our debt. Now, there's some good news to that. All we have to do is generate a degree of cooling, and we can erase the federal debt. Okay, I digress. We have 2.5 pages of things caused by global warming. And that was in 2008, so they've added to the list. All of that's for 0.8 of a degree of centigrade. So if that's not hype, I don't know what is. So let's just look at the facts. Sea level increase. Sea level increase has had a historical rate of 0.07 inches per year. That's not catastrophic, it's not unprecedented, and it may go down if we enter another little ice age. There's no more droughts or storms than normal. And ice melting is normal for the interglacial period that we're in. CO2 is not the cause of global warming. Temperature increases cause CO2 increases. That said, CO2 levels may have an impact on climate at some scale. However, solar activity appears to have a much stronger impact, as does changes in oceanic circulation. So the temperatures from the 1800s to 1988 have increased by about 0.8 of a degree. And from 1998 to present, they've been essentially flat. But a caveat to that is those are based on global average temperatures. The solar activity is at an all-time, is heading into an all-time low, and the PDO is in a cool phase. That does suggest that we could be in for a period of prolonged cooling, not warming. So what difference does it make? Well, let's look at history. And let's go back to the Roman warm. So I don't have temperature data prior to the advent of our calendar, but just in that period preceding the 0 AD, Roman was in a period of civil wars. Then we go into a period of global warming, and the Roman Empire flourishes. Now the reason for that is we have crop surpluses. We have the ability to fund a nation state, and so the empire flourished. Then we go into global cooling, and the crop base shrinks, growing seasons shorten, can't grow wine in Britain anymore, and all of a sudden we go into political strife and turmoil. So warm is good and cold is bad. Let's look at the medieval climate optimum. During the Viking Age here in the medieval climate optimum, the Vikings had established enough agricultural surplus that they were able to start exploring the world. That's when they went and found Greenland. And we had a period of prolonged abundance. And so we were able to create a society where we had people that had time to devote themselves to art and science, and we created, or that was the cause of the Renaissance period. So warm is good. Then we went into the Little Ice Age. That period was dominated by hunger and famine. European powerhouses, in order to maintain their access to resources, set out and colonized the world. So they colonized Africa, the East Indies, Australia, and the United States. Now today we consider colonialism to be a bad thing. So cold is bad. So humankind does better when it's warmer. why on earth would we spend billions of dollars to make it colder? So I'm going to end the talk with a challenge. I offer this challenge every time I make the talk. I would love for someone to show me credible scientific evidence for human-caused global climate change. I haven't seen it in my work, but I'd love to see it. Some caveats to that. Computer models aren't data. So if you think your evidence lies in a computer model, don't bother me. Consensus is not part of the scientific method. So I don't care how many people agree with you or disagree with you. It's not a part of the scientific argument. And finally, ad hominem attacks are not evidence. So for those of you who have certain kinds of names that you'd like to add to my repertoire, keep them to yourself, please. Thank you. The question is, why don't NASA and NOAA use solar curve data on their temperature plots? I have some modelers from NASA at a conference run by APG have admitted they don't know how to model solar activity, so they don't. At least for NASA, James Hansen is an advocate of human-caused global warming, a huge advocate, to the point where he champions civil disobedience in the name of saving the planet. He's also made about $1.4 million selling global warming. So, and it's his agency that have altered the data. So, well, he's an advisor to Al Gore. So I can't really answer the question. I don't know why. I suspect personally that in part they're just not looking for evidence that would show a non-human cause. The IPCC, which funds a lot of the climate research, is not funding anything that would show a non-human cause. That's not their aim. I can't address that. I'm not familiar with it. I will recommend the books by Jared Diamond. The first one I'd recommend is Guns, Germs, and Steel, which talks about how agriculture was influenced not by geography, but it will give you a pretty good idea of, in early civilization, where agriculture was prevalent and what reasons it was prevalent. Then read this sequel to that, which is Collapse, because the collapse does show a number of civilizations that have collapsed due to climate change. A lot of them self-induced. They cut down all the trees and then their climate changed. Not a surprise. So there is some linkage there. I mean, obviously we're talking about an extremely complex system with multiple forcings and multiple causes. But it'd be interesting to see.
President?
In your presentation, you have not made the case that actually the production of CO2 in the U.S. has declined due to switching to natural gas, and we're producing much less CO2 than we did in 1994, enough to actually have met the Kyoto protocols that were required of us, which we didn't sign. And therefore, we are actually heroes in this battle.
Can you